We've talked about ways to find all the 6 pieces, the sides, and the angles of a right triangle using sine, cosine, tangent, and our other trig functions. We've also talked about finding all of the 6 pieces on a non-right triangle, whether it be an obtuse triangle or an acute triangle, using the law of sines. Now, you'll recall that when given a triangle, if we know the angle, side, angle, and side, or if we know side, angle, angle, or if we know side, side, angle, then we can use the law of sines for that to find out the other angle or angles and the other side or sides. But what happens if we have side, angle, side, or side, side, side? That's a different case. In those cases, we're going to use the law of cosines. Now, there is, on page 30 of your book, they derive this formula for you. I'm not really going to require you to know how it's derived, but you will need to memorize the law of cosines. And here it is. It's a formula. I know you guys love formulas. It's similar to the Pythagorean theorem, but it takes into account that it does not have a right angle on it. Now, you can rewrite this with rearranging the A's, B's, and C's depending on which sides you have, so you need to kind of generalize this in your mind. This side squared goes with the angle you're using, and then this side squared plus this side squared goes with this part here where you multiply their side lengths. So we've got a side squared equals the other two sides, the sum of their squares, minus 2 times each of those sides you've already used on this side of the equation, times the cosine of this angle. And again, as always, make sure if you're using degrees, your calculator's in degree mode, and if you're using radians, your calculator is in radian mode. So there's our formula. You need to know that in a general way, okay, where you can apply it no matter which sides and angles you're given. So let's try a couple of examples. Let's say we're given that side A is 38, B is 48, and C is 68. So this is an example where we're given side, side, side. So that means we're using the law of cosines. Now, it doesn't matter which sides we're given. We can rearrange this however we want, but we need to be careful because sometimes we have an obtuse angle in our triangle. If we have an obtuse angle in our triangle, remember your calculator is only going to give you the reference angle. So what you want to do is start by solving the angle across from the shortest side first, using law of cosines across from the shortest side. So this is our shortest side. So solve for angle across from shortest side first. Alright, so once you do that, we see we're going to use this one, which means we want this angle, which means we put it on this side, and then the others on the other side. Now we're just plugging it into the formula. So we rearrange this, subtract these two things off, and then divide by this part. I assume by now you know how to solve a formula like this. And then we'll take the inverse cosine, and we get that angle A is 32.85 degrees. If you're having trouble solving those, make sure you come by and see me. Alright, now once we have this angle here, if we look at it, we've got, remember we're not drawing these triangles to scale, we don't know if they're obtuse or right or whatever, then we can see what we've solved so far. So we solved for this angle here, and now we have a side angle side situation if we want to use that, and we can use our law of sines to finish this problem up. So We take the sine of 32.85 degrees. The easiest thing to do is leave this in your calculator with all its decimals, and then take the sine of the answer so that you keep all your decimals in. And then we're going to find the next shortest side's angle. Okay, work from shortest side to longest side. Okay, and then we cross multiply and take the inverse sine, and we get that angle B is equal to 43.25 degrees. And now, well, how do we handle a triangle? Right, it's 180 degrees, so we take 180 degrees minus these two that we found, and we get that angle C equals 103.9 degrees. Now, notice, this is an obtuse angle. If you had started out with trying to find angle C, you would not have gotten this in your calculator. It would not give this to you. So you need to make sure that you start by finding the angle across from the shortest side and work your way up and use, this is the last, how you find the last angle, always. Okay, always use this for finding your last angle. So, law of cosines. Use your formula, find the angle across from the shortest side. Then you can switch to law of sines. You don't have to. You could have used law of cosines again if you want. You would have gotten the same answer. And find it across from the next shortest side. And then use your 180 degrees to find the third angle. Let's try another one. What if we're given A is 125, B is 85, and let's do it this way. And angle B is 55 degrees. Well, what does that give us? Remember, label your triangle with all its letters first so that you make sure you get your letters lined up properly so you know which sides go with which angles. So A is 125, B is 85, and angle B is 55 degrees. So this is did I line that up right? A, B, C. Oh, sorry. I wondered why that wasn't working right. This is C. Sorry. All right. There we go. Now we can use law of cosines. So we've got side, angle, side, and we can use our law of cosines. So we plug this in. Well, the first thing we want to do is find the side that we're missing. So we have B squared is 125 squared plus 85 squared minus 2 times 125 times 85 times the cosine of 55 degrees, which gives us that B is 103.25. So now we have all three sides, and we have one of the angles. So we're going to use the law of sines, again, looking for that angle that is the smallest, across from the smallest side there. So we'll look for angle C. So we have the sine of 55 degrees over 103.25 equals the sine of C over 85, which gives us that angle C is equal to 42.38 degrees. So cross multiply and take the inverse sine to get that. And then we say 180 degrees minus 55 degrees minus 42.38 degrees, and we get 82.62 degrees for angle A. So the biggest thing with the law of cosines is you've got to be careful to make sure you're solving for those smaller angles first, so that in the end you'll get that obtuse angle if you need it, because these triangles only have one solution. It's not like the case we looked at with the law of sines, where with the side-side angle, where we could have multiple solutions. Okay, these you have one solution. There's only one triangle that fits the three pieces of data they've given us, so we've got to find the three that go with it. So solve for that smallest angle first. And remember, you know the smallest angle because it's across from the smallest side. Think about that. Now, the wider the alligator mouth is, the longer the space is between his lips, right? So make sure you know that formula, law of cosines, and you can use it in a general fashion where you, no matter which sides or angles you're given, and make sure you know your law of sines as well. And if you have any questions, write those down and we'll go over them in class.